All right, today we're going to talk about translations of general functions. So we're not going to be dealing with any type of equations. We're going to just be dealing with a function that we're going to call f of x. And this is going to be our graph that we're going to work with. This represents the function f of x, and we're going to look at what causes changes to this graph based on transformations written in this form. So as you can see, g of x is going to be related to f of x by some change in a number. And that number is what we're going to define as a parameter. Okay, so parameters are going to be what's causing the transformation. So to start, the graph of f of x is shown. Use this graph for the exploration. So we're going to do this down here. So it says first graph g of x equals f of x plus k, where k is the parameter. So we're going to look at changes of what happens when we add a number to a function. What type of transformation does that make? So it says let k equal 4 so that g of x is equal to f of x plus 4. This says when k is a positive number, k is added to the y values to get the ordered pairs for g of x, for the g of x graph. So let's complete this table and then see how it compares to this graph. So to get g of x, we're using the same set of values. Remember, the inputs are arbitrary. Okay, you could pick any input you wanted to. These are just the ones that happen to be there. It's the outputs that are going to change depending on the function. So g of x is just f of x, these values, plus 4. So if we take negative 2 and add 4, we would get 2. If we take 2 and add 4, we'd get 6. If we take negative 2, add 4, we get positive 2. And if we take 2 and add 4, we get positive 6. All right, now let's plot these on the graph, and then we're going to make a conclusion based on what we see on this graph. All right, so negative 1 is paired with 2 on our new function that we call g of x. So at negative 1, 2. Okay, the next point is 1, 6. So 1, 6 is here. Okay, the next point is 3, 2. So 3, 2 here. And then we have 5, 6. So 5, 6. All right, so there's our new graph, and I'm going to label it g of x. So what has happened? What has happened to the graph of f of x, this black graph, to get to g of x? Well, you can see it's moved up 4. All of these are up 4, up 4, up 4, up 4. Okay, so hopefully in geometry you study translations. You do translations of shapes, or transformation, excuse me. And we call this transformation a translation, since the graph has been slid up 4 units. So the next question asks, in general, how is the graph of g of x equals f of x plus k related to the graph of f of x when k is a positive number? Okay, if k is a positive number, g of x is translated up k units from f of x, or you can replace the word translated with shifted, that's fine. All right, so now we're going to try a negative value of k in this form where g of x is equal to f of x plus k. So let k equal negative 3 so that our function is defined by g of x is equal to f of x minus 3. Okay, this is a misprint here. Cross this out. G of x is f of x minus 3, not f of x plus 4. Okay, so we said when k is a negative number, k decreases the y values to get the order pairs to the g of x graph. So let's complete this table. So we take the points, the y values of f of x, because remember, f of x, that's just another name for y. Okay, so this is basically saying take your y's and subtract 3. So we would do negative 2 minus 3 and that is equal to -5. Okay, then take 2 and subtract 3. That's -1. And then take -2, subtract 3 again, that's -5. And then take 2 and subtract 3, that's -1. Alright, I was hoping this would be another color. I thought this was blue, it's black. We'll just have to deal with it. Okay, so I'm going to graph this other function g of x, which is now defined to be, so let's do this so we know that these are different. This g of x is f of x plus 4. The g of x that I'm going to do in black here is going to be g of x, which is equal to f of x minus 3. So plotting those points, there's -5, -1, -5, -1. All right, so there's the graph of f of x that's been moved down 3 units. So the difference in the y values, subtract 3. All right, so we've come up with our rules for translating up and down, and it's that k value. If k is positive, the graph translates up. If k is negative, the graph translates down. So we should go ahead and write that down. It says in general, how is the graph of g of x equal to f of x plus k related to the graph of f of x when k is a negative number? Okay, g of x is translated k units down from f of x. All right, so the last part says in general, when you have g of x equal to f of x plus k, k is the value of a vertical translation either up or down. So I'd probably get a highlighter and highlight that statement so you can remember what the value of k does. All right, next we're going to look at the graph of g of x, which is equal to f of x minus h. So we're going to look at what h does transformationally. All right, so h is our parameter, so let h equals 2. Okay, notice that's a positive 2 there. So that g of x is equal to f of x minus 2. So if h is a positive value, it's going to look like a minus when we talk about the function notation. All right, so it says since h is positive, the h value is added to the x values to get the ordered pairs for the g of x graph. Okay, so since it is happening inside the parentheses, that is going to be a change for x. That's one way to remember it. Okay, another way to remember it is this looks like you should do x and subtract 2, but you actually do the opposite. And the way I remember it, or a way that you can remember it, is to think of any ex-girlfriends or boyfriends you may have had. Okay, and exes lie to you, right? That's why you're probably broken up, because there was probably some lie there. So exes lie to you, so you always do the opposite of what that says. So it looks like you should subtract 2, but really you should add 2. That's the transformation that's going to take place. Okay, so the input for g that produces this -2 output, for f it was -1, but g, we're going to add 2 to those inputs. So the new input for g is going to be 1. The output is still going to be -2. All right, we did not affect the y values there. Okay, If the input of f is 1, the output for g is 3. And the output remains unchanged. Okay, if the input of f is 3, the input for g is 5, and the output remains -2. All right? If the input for f is 5, the input for g is 7, and the output remains 2. So if I write all the ordered pairs for g, this is what I'm left with. And then if I graph that, 1, -2, 1, -2. There. 3, 2. There. 5, -2. And then 7. All right, so there's my points. If I connect them, there's my graph. And that is the graph of g of x, which is equal to f of x minus 2. All right, so it says in general, how's the graph of g of x, which is equal to f of x minus h, related to the graph of f of x when h is a positive number? Well, we just saw that it shifts the graph h units to the right. So h was 2 in this case, so we shifted the graph 2 units to the right. Okay, and I can show that for each point. All right, so we're going to make a conjecture. We're going to make a conclusion without any proof. Okay, how would you expect the graph of g of x equal to f of x minus h to be related to the graph of f of x when h is negative? So I wanted you to first see what this would look like. This would look like g of x is equal to f of x minus -h, which we can rewrite, since you're subtracting a negative, to be g of x is equal to f of x plus h. So if you have an x plus a value for h, that means that h is negative, so g of x would shift h units to the left of f of x. All right, so in general, when you have g of x equal to f of x minus h, h is the value of a, not vertical, so cross out vertical, it's a horizontal translation, either right or left. All right, so moving on, this little chart, I would fill out this chart, okay? And I wrote what it will look like if the sign of h and the sign of k were both positive. This is what the function will look like in function notation. Okay, so what does that mean? That means we're going to shift right h units and shift up k units. Okay, but just because h is positive, remember, that's going to look like a minus inside function notation. It's opposite. When it's with x, it's going to do the opposite of what you think. Okay, if h is positive and k is negative, we're still going to shift right h units. But this time we're going to shift down k units. Okay, if h is negative and k is positive, this is what function notation will look like. So if h is negative, we shift left h units. and shift up k units. And finally, if they're both negative, this is what the function notation would look like for that transformation. So we're going to shift left h units and shift down k units. All right, so next we're going to investigate stretching and compressing functions. All right, so we're going to look at if you have what we're going to call an a value multiplying your original function. So the graph of g of x is going to be related to f of x, except f of x is going to be multiplied by a. So let's take a equal to 2, so that g of x is equal to 2 times f of x. So what do we think is going to change, the x or the y value in this situation? We have to look, is it happening within the parentheses? Because if that's the case, it's going to change x. Well, obviously not, it's out in front. So this is going to be a change in your y value. Okay, so what are we going to do to our y values? Okay, what we're going to do is we're going to multiply all my y values by 2. That's what 2 times f of x means. All right, so my new y values for g of x are going to be 2 times the original y values. So I'm going to do that across the board. And then I'm going to graph those points. So -1 is -4 now. 1 is 4. 3 is -4. And 5 is 4. Okay, so we notice that the x values didn't change, but my y values changed. Okay, and what do we call this? Well, if you can imagine taking the black graph and putting your hands on the top and bottom and then stretching that graph, that would get us to the red graph there, which is g of x, which is 2 times f of x. Okay, so in general, how is the graph of g of x equal to a times f of x related to the graph of f of x when a is greater than 1? Well, we say g of x is vertically stretched by a factor of a. That's how we describe that transformation. All right, so now we're going to try a value between 0 and 1 for g of x. And it's still in that same form. We have a number times f of x. We're letting a equal 1/2. So we're going to describe what's happening here by completing the table and graphing. So just to save some time, I completed this table. I'm going to plot those points. Okay, so we can see that this graph, it doesn't look like it's been vertically stretched. We didn't make it taller. It looks like we've taken those points and squeezed them down. So we call that a vertical compression. So in general, how is the graph of g of x equals a times f of x related to the graph of f of x when a is between 0 and 1? That's what that notation says. G of x is vertically compressed by a factor of a. All right, so in general, I would highlight these two statements. Okay, when a is greater than 1, we say the graph has been vertically stretched by a factor of a. When a is between 0 and 1, we say the graph has been vertically compressed by a factor of whatever number that is, a. All right, so let's do a problem where we have two things going on. Okay, we have this 2 multiplying f of x, and then we're also subtracting 2. All right, so what I like to do when you have multiple things going on, I like to write how to take points from f of x and transform them into g of x. Okay, so we're going to take original xy ordered pairs from f of x. And what does g do to those ordered pairs? Well, let's see. Does anything happen with the x? No, there's nothing inside the parentheses happening to x. So the x coordinate is going to remain the x coordinate. The y values, we have a multiplication by 2 and then a subtraction of 2. So we have to make sure to use the correct order of operations. So we have 2y. We're going to take the old y values from f of x, multiply them by 2, and then subtract 2. So this is what I'm going to call my transformational rule. And if you get used to writing these, it makes transformations so much easier. All right, so how do we get the points for g of x? Well, we just follow our rule. All these x's are going to stay the same, but my y values are going to get multiplied by 2 and then subtracted by 2. So my y value is going to be 2 times negative 2, which is negative 4, minus 2 is negative 6. Same thing here. I'm going to take 2 times my old y, and then subtract 2. That's going to be 2. Since these y values are repeated, we know those values. So now all you got to do is plot these points. And there's my graph. All right, so the first set of practice is just going to be practicing with vertical stretches and compressions and shifting left and right. Let me know if you have any questions.